Now, while that's there, I think that I can go something like this. Yeah, this one. I wanted to change. I don't know. I'll do it later. I can't figure out how to get it going. Okay, we got to get started. So then we are here, and I just had to update it later. Yeah, I don't know why that's like that. Anyway, okay, I'll let it be. So no real announcements. We just kind of need to keep moving through chapter 1 for right now. You kind of want to be ready for exam 1. We'll talk about what sections a little bit later, but be ready for exam 1 next Wednesday. I think so far we're going over at least 2 sections in chapter 1, right? So we want to do another. We just had to push things back because of the holiday we have on Monday. So we're going to keep the rhythm and keep moving forward. Okay. So let's start here. My clock. I don't know why, and then it defaults to that clock, so that's fine. Let's see. I'm assuming that it's working. All right. Anybody watching the live stream now? Can you hear me? Like, I don't know if you can hear me on the live stream. So just make sure everything is working properly. You know, just kind of check it out. Okay. So we're moving into section 1.3 on complex numbers. You can hear? Okay. And then tell me which is louder. If I say apple, or if I say orange. That might be the older stream. But if you can get to the live one, let me just try that test real, because I don't know where the microphone is picking up from. It's from the laptop or from the tablet. If I say apple, or if I say orange. Yeah, so just check it out. Okay. So let's see. I'm realizing that it's picking up on so and all that kind of stuff too. So anyway. So basic concepts of complex numbers. Complex numbers come out of this discussion. So let me see. There's no real number for the solution of this equation where we have x squared equals a -1. Because if we wanted to solve that, we would want 2 real numbers to square to give us -1, right? But if you say a positive times a positive, do we get a positive or a negative? Positive, right? Like if we say 2 times 2 is positive 4. If we say a negative times a negative, or a negative squared, is that positive or negative? Positive, because double negative is positive. So there's no real number, 0 times 0 is 0. So there's no real number such that when we square it, we get this -1. So since no real number when squared gives -1, we're going to extend the real number to a number system to include solutions of this. So we're going to extend it. We're going to introduce this concept called I. Give me a color.
Purple.
I heard blue. Give me a random object.
Square.
Something else. Something interesting.
A gun.
I'm not going to do a gun. I think I heard star. I'll go with star. I heard star. I like star. So I'm going to go here. All right? And then I'm going to go like this. And actually, I'm going to go like this. It's going to be our cursor for right now. And I just want something like that. Okay. And here. So what we're going to do is introduce this concept. In mathematics, when we need something to exist that doesn't exist in the field, then we put a label on it. We just give it a name, and then we introduce it. So since there didn't exist a real number such that you can square to get -1, that's what this term called an imaginary number comes from. It didn't exist, so we just gave it a name. We called it imaginary, and then now we have a whole other system within mathematics. So then I is going to be the square root of -1. Therefore, I squared is going to be -1. Now we have something that exists so that when we square it, we get -1. Is this okay? Okay, so it's just a system outside of the real numbering system. Okay. So if A and B are real numbers, then any number of the form A plus BI is called a complex number, where A is the real part. This is the real part of the complex number, and B is the imaginary part of the complex number. Okay. So two complex numbers, a plus bi and c plus di, are said to be equal, provided their real parts are equal and their imaginary parts are equal. So if we compare these two complex numbers, we're saying that part here, it will go to 0. So then, is this a real number or an imaginary number? This is just a real number. So if b were 0, it will go back to the reals, right? What would happen if a were 0? Yeah, so then we would just be left with I think that's called a pure imaginary number, when it's just something right here. Let's see. So the set of reals is a subset of the complex. Of this form, it's called a non-real complex number, okay? Pure imaginary is where a was 0. We have something there. Okay, I feel like this isn't too bad. And then the complex number written in standard form is going to have this a plus bi. And we might sometimes we put the I before the b if it's like a radical, like a square root. We're going to put the I in front of the b, just for clarity. Let's keep moving forward. What are the naturals? How could you describe the naturals in your own words? This set here. Yeah, positive what? Counting numbers, right? So natural numbers will go 1, 2, 3, 4, 5, so on and so on, right? So anybody know the difference between the natural numbers and the whole numbers? So they're actually the same set, but the whole numbers start at 0 instead of starting at 1. So, but it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, so on and so on and so on. How many natural numbers are there? There are infinity. I like the way that you said that, though. You said too many to count. But infinity is right? Okay, we'll pause right there, because there's a whole discussion behind what you just said. I'm just trying to think of how to say it properly. So, the natural numbers, there are infinity. But if say we did live forever and we could count forever, could we count the set of naturals? Like if we had forever and we lived forever, could we count it? Yeah, because we'll go 1. Can you count it? Yeah, if we had forever, we could begin to count that, right? So my first question is, which set is bigger, the whole numbers or the natural numbers? So these are some of the concepts in mathematics. This is like in accounting. So now the claim is that we say that two sets are equal if we can make one-to-one correspondence. That's the impression that I have. So if we could find a way to pair up every number in the whole numbers to every number in the naturals, then the claim is that they're actually the same size, right? Does that make sense? So then, so watch. So say the whole numbers go 0, 1, 2, 3, so on and so on, right? And then the naturals go 1, 2, 3, 4, so on and so on, right? Is there a way you can map them? Like 0 can be paired with who? 1, right? 0 can be paired with 1. It doesn't have to be the same number. It just has to be a one-to-one correspondent. Every x needs to correspond to exactly 1 y and vice versa.
But it's still gonna be
No, it's not. Watch. Because 0 maps to 1, 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, 5 maps to...
Well, yeah, because it's infinity.
Because it goes on forever, when you offset one of them, it's still the same size. You see what I'm saying? So the idea between... And this is just some actual intro to some advanced mathematics. It's just interesting. It's just to bring the information to life. So... the idea here is that the natural numbers and the whole numbers are actually the same size, even though it's just one set is offset, but they're actually, the claim is that they're the same size because we can make a one-to-one mapping between the two sets. Now, if that's the naturals and the whole numbers, what are the integers? Yeah, so you have 0, you have the positive counting numbers, and then we have the negative counting numbers, right? So then the next question is, if we're comparing the integers to the naturals, which is bigger, the integers or the naturals? Or what does your intuition say based on our previous discussion? So intuitively, you should see where this... Now, this is just background discussion. You don't have to know all this. We're just playing around. But intuition, based on our previous discussion, would say, well, based on that, they should be the same size. But then if they are the same size, the challenge is can you show a one-to-one mapping? Is there a way you can line up the integers to line up with the naturals in the one-to-one mapping?
Yeah.
So, okay, so if you said, I heard -1, 1, what does that mean?
They're paired.
Okay, so you're going to pair.
Zero. If you add them, I don't
So
know.
what's the how do we line them up so that they match? Because the integers go like this, right? The integers go 0, 1, -1, 2, -2. So how can we match? No.
You can't. Because you can't go to negatives with natural numbers. And it's, so it's like it's going to always be that negative part that's still.
Just by a show of hands, I'm just curious. By a show of hands, how many people think there does exist some mapping where they would match up? Like, how many people think that they are the same size? Intuitively. How many people think that you can't? There's no way to map it. Okay. I kind of want to leave that as an exercise, but I'll go ahead and satiate it for now. I know, but I have to mention it because it's so interesting, and it's not at this level. It's not that bad. Watch. So I'll go ahead and give this one to you. So now we have the energy. You see it up above, right? If we can make a one-to-one mapping align with 0 like this, we're going to put 0 there, right? So 0 is going to go there, and it'll map up with the same kind of mapping it had before. But then now we're going to let me see. We're going to take the positive counting numbers and map them to the odds, right? So if we take the positives, so we're going to let me see. Yeah. We'll go like this. We'll say 1 goes to 1, 2 goes to 3, 3 will go to where? 5. So we're going to let the positives align with the odds. What do you think the negatives align with? The even. So if we take the negatives, like -1 goes to 2, -2 goes to 4, -3 goes to, what is that, 6, right? Now, with this rearrangement.
You can say we can do that.
Well, that's why we're having this discussion. Okay? With this rearrangement, now can you see the one-to-one mapping?
No, I do not accept that.
That's called being in denial. It's clear. You can see it, right? Because is it safe to say that the entire integers are in that upper set? Yeah, they're all there. So I mean, that's how. Okay, so what you're experiencing is what happens with the actual work that you all do. It's math is all about pattern recognition, and then it's just like a collection of little tricks, and little manipulations. But it's like you're not aware of them if you don't practice. I'm not saying you all aren't doing the work, but what happens with students typically they don't do the work. And then they try to come in like the day of the exam, and they don't know the little nuances. And so the only way you're going to discover the nuances is by having these discussions, exposing yourself to the concepts, practicing, working together, coming to office hours, asking your professors. The only way these things come to light is through exposure. And so it's like you're not going to be aware of it if you don't expose yourself to the concepts. So, it's just I just wanted you to kind of be aware of that. The claim is that the integers are the same size because we can create a one-to-one mapping between all the elements of the integers and the naturals. So the claim is that they're the same size. And the discussion continues. Like it goes further because you can extend it to the naturals. Then there's more discussion between the irrationals, the reals, and there's more as far as counting, as far as sets being larger or not. I'm going to kind of jump ahead a little bit just for the sake of time. Rationals are going to be ratio of two integers where the denominator is not 0. So basically fractions, right? And then the next logical question is, which set is bigger, the rationals or the naturals? There is a discussion there. If anybody can kind of explain to me maybe like either an email or something outside of this space and time right now, just explain to me which set is bigger between the rationals and the naturals. I might be able to throw extra credit your way. Maybe even double, maybe. But just explain it. Look it up. Explain it to me either in an email or after class or something like that. Just which is bigger between the rationals and the naturals. Think about that. Look at it. See if show me what you can find. And then irrational numbers these are non-terminating, non-repeating decimals. So if you have a decimal, numbers that you can't write, these are decimals that go on forever and that don't repeat. These are irrationals. Okay. Then the next question is, which is larger, the irrational or the naturals? There's a discussion there. there's an opportunity for extra credit there as well. I want to have two different people though. So if you get one extra credit, leave the other one for somebody else. Okay. So, but tell me which is larger, the irrationals or the naturals? I need you to explain that to me. Okay, or the reals and the naturals. Explain that. Okay. But the reals is just going to be the rational numbers with the irrational numbers. Okay. So don't worry about that back discussion that we had. That was just a side discussion on counting. And there's more. I want you to kind of do a little bit of research and tell me what you can find. Now, outside of the real numbers, that's where the complex numbers are, the blue region that we have. Okay? It's just a whole nother system. Okay, I think this is okay. I feel like there should be questions. I left some things as a mystery and some things open on purpose. Any other questions, comments, or concerns? Okay, so we're going to let that be for right now. So the square root of negative a. So if a is a positive, I think it's going to be a real number. Then the square root of negative a, we said earlier that the square root of negative 1 is going to be I. So then the square root of negative a is going to be I times the square root of a. Is this okay? All right. Okay. So give me a color. All right. So if we have the square root of negative a, this is the same as square root of negative 1 times a, right? In this context, we can do the following. We can break it apart as follows. We could say square root of negative 1 times the square root of a, then we get this. Because we said, by definition, and then I, the imaginary number I, is going to be the square root of negative 1. By definition. Okay? Okay. That's what we introduced today with complex numbers. So we're just introducing a new concept. It's really light today. I'm trying to keep it as light as possible. It will get a little bit funky. All right. Say we have the square root of negative 16. That's the same as what? Square root of? Okay, yeah, I think that's straightforward. Because it's the same as the square root of negative 1 times the square root of 16. It's going to be I. Square root of 16 is 4, but I'm going to rewrite this as 4i. Is that okay? Yeah, we're going to get into that. That's coming up. Yeah, the powers of I. There's a pattern there as well. Again, this is all about pattern recognition. This whole mathematics is all about patterns. So if you get bored really easily, only boring people get bored. That's why my energy be so high. It's overwhelming for me for a lot of times, but I don't get bored. So that I don't get bored. Like when I talk about this stuff, it's no boredom. There's always something interesting to talk about.
Okay, I'm sorry.
Go ahead. Is there something not clear?
I'm trying to write it down so I can remember it.
So keep in mind, everything that you see on the board, I'm going to load a copy of. You'll be able to get a copy of.
Not that. The one before that.
This one? And then, so anything that like the green stuff, that stuff is on Moodle. So you actually already have a copy. That's why it's a good idea to print out a copy of, or have some access of this before you come into class. Either print it out or have it loaded to like a tablet or something like that. So that way you only need to write what I write. And actually, you're actually going to get a copy of what I write, So just keep in mind that you already have this already. I just want you to be aware. Okay. So 4i is good. Let's keep moving forward. Okay. Let's see. Come on. No? Okay. So what solution did you get? Square root of 70. Okay. I heard I times the square root of 70. I think that's straightforward. 70 is what times what? Are there any perfect squares inside of the 70? Because it's what? 7 times 10, right? And 10 is 2 times 5. So it's no perfect squares. So I would agree with this result.
Oh, that's it?
Yeah, I would agree with that. Because there's no perfect squares in there. All right? Let's keep going. Negative 48. All right. So this is the same as square root of what times what? Negative 1 times 6 and 8, right? I heard a 6 and I heard an 8, right? But let's keep going. 4. 6 times 2. Yeah, no. So we'll do it like this. I'm just trying to think of the best way. So we can say 16 and 3, right? I heard these numbers. I heard 4, but then we still have what? 4 and 3, right? Here, let's just do this. Let's do this. Because there's a number of ways. Hang tight. You can either say 16 times the square root of 3, but let's break it all the way down, right? So we're going to have negative 1. 6 is 2 times 3, and 8 is 2 times 2 times 2, right? See where those numbers came from? 8 is 2 times 2 times 2. 6 is 2 times 3, right? So now since we're doing square root, we want groups of 2. So look, so here's one perfect square right there. Here's a second perfect square.
I remember this.
Okay, we're right there. We're there. So then that's a 4 and a 4. So on the outside, we're going to have 16i times the square root of 3. Because 3 was the only perfect square. Give me a color. Wait. Is that not right? It's 4? Oh, okay. Hang on. Don't jump down my throat. I am human after all. Hang tight. So I'm moving a little fast. Hang tight. So 2 times 2 times 2 times 2 is 16. That's where I was getting 16 from. Square root of 16 is 4. Right? Right. So then you still got your I square root of 3. That's much better. And we were going to see it in just a second. But yeah, 4i square root of 3. Any questions here? Okay. So yeah, this is good. All right, let's keep moving. That's a typo. It just didn't come out proper. It just didn't print properly. But we get our 4i square root of 3. Any questions? Okay, I'm going to move forward. Man, y'all were ready. I like that, though. I like that y'all were ready. I want you to stay like that. Okay. Because I definitely make mistakes. Now, I will say this. If I walk away from a question, and if you had let me walk away from that, and I went on to the next one, and it was wrong, and then you say, hey, Mr. Pfeiffer, I think you made a mistake, I had to walk away from the question, though. I didn't walk away from it because I have a habit of checking. There's a thing where successful people, not that I'm successful or anything, but habits of successful people, they typically check, double check, triple check, this kind of thing. So before I walk away from questions, I typically check. So if I walk away from a question and I don't check it, and it's wrong, and you say, hey, Mr. Pfeiffer, that last example, I think you made a mistake. And then if you catch a mistake like that, I'll give you extra credit. So with that one, I would have to walk away from it, and then I would have given you the extra credit. Yeah, you had to wait. But that's what I'm telling you now. So you got to wait because I checked my work. That's the only reason I minimize my mistakes. Okay? Yeah. So if I walk away from it and it's wrong, I'll give you extra credit if you bring it to my attention. Let's keep moving forward. Was there a question? I felt like I was ignoring a hand. Okay. All right, so the products of quotients, let me see. I'm going to let this be for right now. Okay. So you want to be careful. You want to be sure to work with the negative first when dealing with negatives inside the radical before doing any other rules for radicals. Let me see if I can see an example. Okay, right here. So notice, in this first example, we're going to have the square root of c times the square root of d. If we're dealing with positive numbers, it is equal to the square root of c times d. But this is only valid when c and d are not both negative, right? So if we look going down, we have negative 4 times the square root of negative 4 times the square root of negative 9. The square root of negative 4 is going to be what? 2i times 3i, right? But then 3 times 2 is 6. I squared, what is that one again? I times I is negative 1. So you see that first row is negative 6 done in that fashion. Let's compare that to the second line. Now, if we were to say the square root of negative 4 times the square root of 9, and we move them both into the same radical, now we're going to have, what's negative 4 times negative 9 is what? Positive 36. We'll take the square root of positive 36, we get a positive 6. So what we're saying is that when we have negatives inside the radical, the first line is the correct way to do it. The second line is the incorrect way. If they were both positive, then we can do either or. We will get the same result. But because we have negatives, the preferred method is the first row where it says correct. Questions, comments, or concerns? Do you see the difference between the two? Is it okay? Okay. So, just do your best, forget the rest, don't stress and be blessed. That's the simple. Don't do your best, forget the rest, don't stress, be blessed. Unless the stress is like helping you to do what you need to do, a lot of times it blocks the students. It causes students to shut down, get headaches, So don't stress. Don't worry about it. I'm not trying to trick you. I'm just trying to deliver the information in a concise, clear way. All right, I'm going to move forward. All right. So this one asks us to multiply. We have the square root of 7 times the square root of 7. Sorry, square root of negative 7, square root of negative 7, right? No. Give me a color. I think I heard purple. Okay. So now, when we're working with negatives inside the radical, the suggestion is work with the negative first, right? So what does the first one become? Okay, this first one becomes I square root of 7. Same thing for the next one, right? I square root of 7, right? We can rearrange it. What's the square root of 7 times the square root of 7? So square root of 49, which is, okay. So we can say square root of 7 squared. That's going to cancel, right? What you all are saying is correct. And then the second part we get is I squared. So we use the associative property of multiplication. What's I squared again? Negative 1. What's the final result here? Negative 7. Negative 7. It's not obvious. It takes practice. Right? Is that right? Wait, let me make sure. We get I squared. That's a negative. Yeah, negative 7. Any questions there? Do I need to redo that?
I'm confused about. Did you cancel out?
Hang on, I can't. There's some chatter. Hang on in the back. Hang on for a moment. Hang on. Go ahead.
Did you cancel the entire?
I said the radical. Yeah. So square root squared, it cancels. Yeah. Because it's a square. The square root of 7 squared is the same as the square root of 49.
Oh, okay.
Yeah. Because you could have put the square root of 49, then you'll get 7. It's the same thing. Okay. But it does take practice. I want you guys to be sure to practice. Don't assume that you know it. Just do it. Any other questions? Okay, I'm going to move forward. Because you know what happens when you assume, right? Assume means it makes an ass out of you and me. So don't assume. That's what it means. Assume. Yeah, it means you're making an ass out of you and me. So don't assume. Yeah, don't assume. Okay? So, okay. All right, so let's move forward. All right. Okay, I don't want to see the solution now. Okay. So now, let's look at it. All right, so first we want to handle the negatives. Give me a color.
Red.
Okay, we can do red. I'm not partial to red because usually it's so harsh, but I'll do it. So now, the first one, we got the square root of negative 6. What happens there? Okay, I square root of 6. We're going to leave it just like that. Tell me about the next one. I square root of 10. Now, when we rearrange this, what happens? We get what? I times I is I squared. Okay. So I squared is negative 1. And then what happens with the radical? What can we do with that 6 and the 2? 6 and 10. So we'll get 60, or I like how you all are doing it better. I like that you're breaking them down. So the 6 becomes 2 times 3. The 10 is 2 times 5. Is this okay?
No, because that's a square thing. 2 and 2 right there.
So I'm not done. I just broke the 6 apart into 2 and 3. I broke the 10 into 2 and 5. Now I'm looking for my perfect squares. Let's do this color. So here's one group of 2. So square root of 4, that's going to be a 2 on the outside. And then, so what's the result? So there is a 15. We do have a 15. Is that inside or outside the radical? That is inside. Tell me about the outside. It's just 1, 2. And here. Clean it up. I squared is negative 2 root 15. Takes practice. Takes practice.
Okay, did it matter what order you put the...
I did that so that I can group my like terms.
Oh, okay.
Yeah, because that's the commutative property of multiplication. 2 times 3 is the same as 3 times 2. So you can, in this context, you can change the order around and preserve equality. Okay? So negative 2 root 15, and it looks good.
Why are the question marks
It just printed out. It just didn't print properly. This is why we're doing it by hand together. Those are typos. Yeah. I just printed it directly from Pearson. It just didn't come out properly. Okay, I'm going to move forward. What's the time? We started at noon. We got 125. Okay, that's fine. We'll get it working. Let's do the following. I need to make sure this is going around. Where is it? You can go there. You have been logged. So be sure to print your name on the attendance. Attendance is coming around. All right, let's move forward. How many more slides? We're not even halfway. I'm going to pick up the speed a little bit. Okay. So this one. All right, so I'm going to just kind of move a little bit. I need another color. Orange is fine. So now, I'm going to break it down. We know that the first one is an I, right? 20 is what times what? 10 and 2, right? But 10 is what times what? 2 and 5, right? So that's 20 broken all the way down. The bottom is just I squared root of 2, right? But we can do the following. Something divided by itself goes to 2 divided by 2 is 7 divided by 7 is. So I divided by I should be 1. Okay, so I'm going to cancel these, right? But I'm going to move these the remainder into the same radical. We should be able to do the following. So we're going to have 2 times 2 times 5 over 2, all inside the same radical. What happens? Now we can do what? Now we can do what? If we got 2 on top and 2 on bottom, this cancels that, right? So what's the final result? Square root of 10, right? Again, it takes practice. They did cancel their I like we did. And yeah, they moved it into the same radical the same way we did. I just kept mine separate. They went on and made the bigger numbers. I'm a fan of keeping them separate. For me, it's easier to see what cancels. But it takes practice because sometimes students like to cancel incorrectly. You can't cancel across addition and subtraction. It has to be... So we essentially did the same thing. I just kept my numbers separate. Yeah, 20 divided by 2 is 10. I canceled the 2's. But I do that because sometimes the numbers get large. And when you get those large numbers, sometimes it's easier to make a mistake. For me, it's easier. It's a little bit more work, but it's easier when you space it out. Then it's easier to keep track of your cancellations. This is just me. You don't have to do it this way. You got to find your own personal way. Again, this is how I express myself. How you express yourself might be different. You just want to make sure that you're doing it in an appropriate way for this, okay? All right, so, you know, there's more than one way to skin a carrot because I don't want to skin any cats, okay? All right. Anyway, all right, let's give me a color. All right, I heard pink. That's fine. It's a little bold. All right. So if we do the same thing, square root of negative becomes I. 48 is what times what? 8 and 6, right? So 8 is 2, 2, 2. 6 is 2 times 3, right? That's the top. Let's look at the bottom. Any negatives? What times what is 24? 6 and 4, right? So 2 times 2, 2 and 3. Agreed? So then what I'm going to do, I'm going to move them into the same radical. 8, 6. I don't like that last 3. And then this is 1, 2, 3. This. Now, in this form, for me, it's super clear as to what cancels. What cancels? Square root of 2. Now, you don't have to do it that way. This is my way. There's more than one way. That's correct. The book, let me think about this. Give me a second. I think that this is the typo. That's not supposed to be negative. That's not supposed to be negative. I'm going to say this is a typo. So on an exam, just bring it to my attention and just ask me, and I'll tell you. Okay? So now, if we take that away, notice they kept the 48 divided by 24 off the top of my head. I don't automatically know. For me, it's easier to kind of keep everything spaced out. You decide what works for you. Because sometimes the larger numbers are easier, and sometimes the spacing out is easier. Go ahead.
Can we reduce the 48 and 24 first?
Yeah, that's essentially what I did. Yes. Yes. What you're saying?
To like divide both of them by like.
Yes. Yeah. What you're saying is correct. You can do that. You can divide them both by 12. Yeah. Because you're gonna have to reduce it again. Yeah. Okay. Yeah. Okay. These are fair questions. So my philosophy when it comes to questioning with this kind of stuff, my philosophy is the only dumb question is the one not asked. So a lot of times if you just ask, it's just a simple yes or no, then you go from there, you know. But my philosophy is the only dumb question is the one not asked. Because a lot of times questions that you all have, somebody else has the same question. So ask it because you don't know who you're helping, you know. And again, this whole time period of being in class together like this and the homework, that's when you want to make your mistakes. That's when you want to ask your questions. You don't want to wait until the exam to ask these questions because then it's too late. Okay? All right. I'm going to keep moving forward. The time is looking good. I'm going to keep moving. All right, and we're about halfway. I need to pick up the pace. Now, we want to write this in standard form. I'm just going to kind of use the slides that are already here. So the 128, what times what is 128? I don't know. So what I'm going to do, I would do this. Off the top of my head, I'm not going to know. So what I'm going to do, I would do the following. 128, well, you can at least see that it's what? Divisible by what? By 2, right? So 2 times what? There's a 64, right? What times what is 64? 8 and 8, right? So then 8 is 2, 2, 2, 2, 2, 2. So then I will do my canceling. Okay? It should. 2 to the power of what? 6? Hey Siri, what's 2 to the power of 6?
2 raised to the 6th power is 64.
So maybe 7? Hey Siri, what's 2 to the power of 7?
2 raised to the 7th power.
So it should be 7 2s there, right? Give me a color. I heard brown. Brown is, hey. All right. So 1, 2, 3, 4, 5, 6, 7. 7 is correct. Okay? Anybody get that reference? I said 7. You get that reference? 7. 1, 2. What is that? Yeah, okay. Yeah, Sesame Street, Count Dracula. I was like, I know I'm not that old. I know. But that's where I got it from. Okay. So then, now, if we're doing the square root of that 128, notice we have 7 2s. So we want to circle every group of 2. If that was inside the radical, right? Here's one group of 2. Here's a second. Here's a third. So on the outside, we're going to have 2 times 2 times 2, which is what? 8. Let's see. That's where this 8 right here comes from. And then there's 1 2 left over. That 2 is right there. Does that make sense? Okay. So again, you don't have to do it this way. I'm just showing you one way. You got to find your own way. So if this is a bit much, just ignore it. You're going to have to go, outside of class and sit, and figure out your own kind of way. You don't have to do it this way. I'm just showing you. I'm showing you at least one way. I'm showing you that it's possible. You got to find your own path. Okay. So we did that. The negative became I. The square root of 64 became 8. So now we have the negative 8 plus 8i square root of 2. Both of those on top get divided by what? 4, right? So negative 8 divided by 4 is negative 2. And then 8 divided by 4 is 2. So the final result is right there. Okay? It takes practice. Okay? You don't have to do it the way that I'm doing. You just want to find something that you're comfortable with and work it. And make sure that it works on a consistent basis. If you're consistently getting them right, run them past me. I say, yeah, you can do that. That's fine. Okay, I was like, oh, well, it might not work in this scenario. That kind of stuff. So you don't have to do it the way that I'm doing it. All right. Now, so I'm gonna load a copy before I walk out of the room. I'm gonna load a copy. Okay?
No, that's not what I asked you.
Okay. Yeah. So I will load a copy. All right. Let's see. So we have two complex numbers. Okay. So when we add complex numbers, we say the real plus the real, the imaginary plus the imaginary. It's like combining like terms, basically. Same for subtracting. Okay, let's see it in action. So if we said 3 minus 4i plus that second complex number, 3, we say 3 plus what? 3 plus -2 gives us, that's okay. It's a 1, that's fine. -4i plus 6i gives us 2y. Because it's really 6 minus 4. It's okay. It gets a little bit like that. Again, your confidence, your being comfortable with the information comes from repetition. When you get on the exam day, if you're not comfortable and confident, that means you have not been doing reps. I don't have to ask any questions. I'm already going to know. And it's very clear each time. The students that have been doing my work, that get the reps in, when they get in the exam, they see it's the exact same thing. I'm not trying to trick you. It's the same thing with different numbers. So the only way you're going to be uncomfortable on the exam is if you have not been practicing. It's like with anything. When you go to do a performance, if you're singing and dancing and you haven't been practicing, what happens? It's going to show. You're going to be out of rhythm, out of sync. You're going to stammer over your words. Why? Because you have not gotten the reps in. This is the exact same as anything in life that you want to do. If you want to be proficient, you got to get your reps in. It doesn't matter. It's all the same thing, just different energy. Okay? Think about anything that you're good at. Did you do it once and you were perfect at it? No. You do it day in and day out. You can do it in your sleep sometimes. You've had dreams about whatever it is that you love to do. That's how good you are. This is the same thing. This is the same thing. Yeah, it's the same. It's the same. Okay. Combined like terms is a better way with this one. This one we didn't FOIL. We did combined like terms. Okay, I'm going to keep moving. The time. Okay, let's see. Now, subtraction is addition. We just need to do what? We need to distribute. Well, because okay, look, if we said -4, what are we doing with the -4 and the 6?
You combine it, addition.
Yeah, you see what I'm saying? So, yeah, so let's do this. Let's do this. Let's go. Let's distribute this negative, right? So then we're going to get...
-10.
Wait a second. Plus, now it becomes a -6 plus 7i. So we had to rewrite it. Let's do this. We want this. Notice that this changed, and this changed. And we want those to be something vibrant. You see that? We distributed the negative. Now we're at addition. Now we're back to what we had before, right? So now, what's a -4 plus a -6? -10. What's 3 plus 7? 10i, right? -10i. Without that distributed negative, it's easy to be led astray. Is that fair? Go ahead. Is it okay? Okay. Because if we try to do it right off the rip, we could have easily put 2 and, I don't know, -4. It's easy to get lost if you don't distribute that negative. That's fine too. Because once we go to take the exam, yeah, it's gonna be open notes, and I would say anticipate a multiple choice exam. So it's gonna be all or nothing. So you want to be precise, accurate, and precise. Okay. Can somebody explain to me the difference between accuracy versus precision?
I know.
I saw the hand in the back first, though.
Accuracy is 100% right.
Okay, what's...
Precision is how you, it's called orchestrate? Like how you do it.
Let me see here.
Precision is closeness, accuracy is exactness.
Yeah, that sounds right. Yeah.
We learned that in
So
science.
yeah, precision is like you said, it's 100% right, being on the money, right? Like, or did you hit your target? But accuracy is like closeness, like on a consistent. You're like.
I thought it was the other way.
Did I get it backwards?
Yeah.
Precision. Yeah, precision is when you do it over and over. Are you consistently getting the same thing? Accuracy is being on the money. Yeah, but that's the idea. See again. Yeah, but you got it. So precision, accuracy. Yeah, accurate. Yeah. So again, one is about when you do the reps, are you getting to the same thing on a consistent basis? The other is being 100% right. So that was good. I was just curious. So yeah, that's what's going on here. Okay, so you guys got me beat. I'm gonna let that be. I'm watching the clock. I'm okay. I'm gonna keep moving. All right. So now I heard the solution earlier. I heard the solution to this next part earlier. You guys were just a little ahead. Now, if we're multiplying complex numbers, now we want to do what? Now we want to FOIL, okay? So now this is going to be FOIL, okay? So yeah, if we're multiplying two complex numbers, we're essentially going to FOIL. And everybody know what I mean by FOIL?
Yes.
First, outer, inner, last, okay? What's the solution here?
That's 6.
Okay, I heard 6.
That's 6. Then it's
I heard a 6. So first and first is 6, okay?
-9i.
I heard an 8i. I heard a negative 9i.
Any negative
-12i to the second.
I squared. What's I squared again?
-12.
So then negative 12i squared becomes plus 12. Okay. All right. So 12 and 6 is what?
18.
18. 8i and 9i is
That's -i.
negative I. Sounds good. Is that right? Any questions there? Okay, let's see.
Oh, okay.
8. All right.
But you can simply, I would say you can simplify more than that.
That's it.
Not -i. You can't turn -i to nothing.
This is standard form. Yeah. We got our a plus bi. What's our b in this case?
-i. It's
But A is regular.
If it's a plus bi, what's the number from
negative.
-1? -1. Yeah. So the b in this case is -1. What's the a? 18. Okay. Okay. And this is a typo. This is supposed to be. This is close enough. No, I like this one better. This is supposed to be I squared. Okay. Let's keep moving. What's the time? 44. Okay, getting close. That's okay. What's it? Okay, I'm gonna move a little faster. Now, if you got something like this, you got 4 plus 3i squared, what would you do to make it look like the last one?
Put it into the slide.
Yeah, you write it times itself. So squared means something times itself. Then we're back to what we had before. So then we will FOIL, and we should get this result. I'm going to leave that as an exercise. I think you can do that. Anybody know what's going to happen here? Okay, if we...
The 2 are going to cancel out.
Yeah, they're going to cancel it. Yeah, no, that was it. That was the whole point. So this is actually a shortcut. We got a plus bi times a minus bi. And so if we FOIL here, right? First is what? 36. Outer minus 30i. Inner plus 30i. And last is minus 25i squared. So she got it on the money. These cancel, right? I squared becomes positive. What is that? 41? Is that right? 41? $61. So 30, all right, 61. But the whole point is the two middle terms cancel. And then I squared became positive. Let me see, that's a 50, yeah, 61. Okay. Is this okay? Any questions, comments, or concerns here? All right, so in the last example, we showed that a plus bi times a minus bi, it was basically a squared plus b squared, right? So when we folded, the two middle terms canceled, and it was just a squared plus b squared. So if we say a complex number, anybody know what that's called? When we say if the first complex number is a plus bi, then the other one is a minus bi, what is that other one called? It begins with the C. If the first complex number is 6 plus 5i, and the other complex number is 6 minus 5i, what is that 6 minus 5i called? Conjugate. Yes, on the board. I see it in the future, right there. The power of observation. Okay. So, I mean, I've done that same thing with students in the past. I say, what is that called? And they're like, they won't read. You know, reading is fundamental. It's not cheating. You got to be observant. You know, use your, whatever. Anyway. But yeah, so a conjugate, a complex number times its conjugate, the shortcut is a squared plus b squared. But if you didn't know that, you could FOIL, you get there as well. Okay, so you don't have to do that. But a complex number times its conjugate, and when we say conjugate, are we changing the sign of the real part or the imaginary part? The imaginary part. So the conjugate of a complex number, we flip the sign of the imaginary part. All right? So for two real numbers, a and b, When we say a plus bi times a minus bi, it's just going to be a squared plus b squared. All right. I need to show you this. So we want to write this in the standard form a plus bi. So the reason this isn't in standard form is because we have a radical in the denominator, right? So to get rid of that radical, can anybody think what can we multiply the top and the bottom by in order to get rid of the radical? Yeah, that is the what of the denominator, the conjugate, right? Yeah, this is it. I'm liking this. This is good stuff. I'm taking notes. Where's my attendance? Who else needs to sign the attendance? Okay. All right. So yeah, we're going to multiply the top and the bottom. We're going to multiply by 1 because 1 times anything is itself. But we're going to multiply by 1 in the following form. Give me a color.
Green.
I heard green. So we're going to multiply by 1 in the following form. I heard the conjugate. 5 plus I. 5 plus I. Okay? So then we're going to FOIL, right? Okay? Keep going. So the top, if we FOIL, we get what? 15, 3i, 10i, and then what? 2i squared, right? But on bottom, what's the shortcut? A. So that's what? 25 plus 1, right? So if we keep going, I squared is negative 1. So what happens? So then 15 and... So negative 2 is correct. And then 13, right? 13. And then plus 13i over what number? Try again. 26. And then to take it one step further, what's 13 over 26 becomes? A half. That's a half. We can write it. How do I want to write it? We'll do, should be, where is it? There it is, a half. We'll do it as a half. Where'd it go? Yeah, so this becomes 1/2 plus 1/2 I. But it's fair game. It can pop up. Go ahead. I squared. I times I is I squared. And then I squared is negative 1. All right. No, you're not. It's okay. This is information overload. So it's a lot. It's simple concepts. It's just a lot of information.
I feel like when we get to stuff like this, the stuff that we really remember.
Yeah, that definitely happens. Again, the confidence and the level of being comfortable comes out of repetition. So that's where the homework, the practice, okay, all that kind of stuff. I want to finish out these slides. I'm going to leave this as an exercise. No, that's the one we were just doing. All right, what's the conjugate of the denominator here? Yeah, negative I. Okay, so then the top becomes a negative 3i. So negative I squared, right? I squared is negative 1, so negative 1 is, so then the final result is negative 3i, okay? Practice it. Don't take my word for it. Let me see. Negative 3i, right? That's what we have. So I squared is negative 1. So then it's going to be negative 1. Double negative is positive 1. So then negative 3i divided by positive 1 is itself. If you work it, you'll see it. You'll see it. Yeah. It's just because you're hearing it out loud. You got to kind of work it, and you'll see it. You'll see it. Just work it. You'll see it. All right. I'm going to let this be. So then there's that. Okay, powers of I really quickly. All right. I'm going to kind of do this here. All right. So give me a color. Something I keep forgetting. This one? This one?
None of them are indigo.
This one? Yeah, that's why I was. I'm going to choose this color. Okay. So let's look at powers of I, right? So we're going to let I to the power of 1 is just I, right? We said that I squared negative 1, right? All right. So then I cubed, well, we can rewrite this as I squared times I, right? But I squared is what? So then this is ultimately just
Negative I.
negative I. If we have I squared times I, how is that I to the third? What do we do with those exponents? Uh,
What did you know?
when we say, right, okay, give me another color. I'm going to do this, right? Right here, look. How is it, when we have I squared times I to the 1, what do we do with those exponents? We add the exponents because they have the same base. So 1 plus 2 gives us the 3. Okay? So then I squared is negative 1, and that just stays as I, so we're here. Okay? So now let's keep going. So now I to the 4. Well, we can rewrite that as what? I squared times what? I squared. But then what's I squared? Negative 1 times negative 1, which is 1. All right, let's keep going. Tell me about I to the 5th. So then I to the 4 times I, right? Same argument as before. But I to the 4 is what? So then this is ultimately just, is that okay? Let's do it again. I to the 6. Well, this is I to the 4 times what? I squared. Hang on. You see it? I know you see it. I to the 4 is what? 1. I squared is negative 1. Okay, so then I to the 7 is I to the 4 times I cubed. Well, I cubed, this should be negative I. And then the last one, I'll put it over here. I to the 8, which is, every multiple of 4 ultimately is what? It repeats, right? So notice the powers of I repeat every 4, right? Every 4 repeats. Let me organize this data a little bit better. Every 4 it repeats. Give me just a moment to organize this. So we're going to go here. I want to shrink this down. Nope. Back up. Hang on. Wait. Give me a moment. Just let me finish. Give me just a moment. So I want that there. And then I want this. I didn't really want that, but that's okay. I'm going to shrink this down. Put it side by side. Just like that. I don't need this guy anymore. But this, just like that. All right. So now that's a lot better. So now notice, every power of 4 repeats, right? So whenever we're doing the powers of I, we should get one of the 4 results. Now, let's see it in action. Let's give it a go. So we did all this. We did that. Okay, yeah. So here's what we just wrote out. Here is the powers of I. All right. Let's give it a go. I want to work an example. I to the 0. I think that's supposed to be a 1. I think that's supposed to be I to the power of 0. Let me go ahead and fix that. Is that right? Because something to the 0 is 1. Okay. So now let's look at the first one. We got I to the 15, right? What's the closest power of 4 below 15? Sorry, closest multiple of 4 just below 15. 12, right? So I to the 15, ladies, hang tight. So I to the 15 is going to be I to the 12 times what? I to the power of 3, right? Every multiple of 4 collapses to 1, right? So this is really just 1 times I to the 3rd, and I to the 3rd is negative I. So then that one should just be negative I. See it. So let me move this down so it's on the same slide. Is that okay? Let's do another one. All right, let's look at B. We got I to the negative 3rd. What does a negative exponent mean? It goes to the... What does a negative exponent mean? To the denominator, right? So, I to the negative 3 means what? 1 over I to the 3rd. So then I to the 3rd, what is that? Negative I think, right? Negative I. But we can't leave the I in the denominator. So we need to rationalize. So then we multiply the top and the bottom by the what of the denominator? The not reciprocal, conjugate. So we're multiplying by 1 in the following form. I over I. The conjugate of the denominator is I, right? So then the top just stays as I. The bottom, now I times I is I squared, so that's a negative I squared.
So it's negative I. No, it's just I.
So it's just I. Yeah. All of that for this. Yeah.
Wait, so it's I?
Yeah.
Not 1?
Yeah, what you're saying is right. So look, I squared is negative 1, right? The bottom. Let's just look at the bottom. Just the bottom. I squared is negative 1, right? Yeah, I don't know if that's big enough. I'm trying to get it bigger.
No, that's...
I know, I just been saying. But look, I squared is negative 1, right? Negative 1 times negative 1 is positive 1. Something divided by 1 is itself. That's where they are coming. Okay? Okay. So if you work it, you'll see it. Okay, yeah.
Okay, yeah. Okay.
So again, trying to listen to it and follow someone else is confusing. If you do it yourself and then compare at the end, I think that's the best tactic. I'm just giving you some audio, to kind of complement it. Okay? What's the time? I want to kind of wrap it up. Yeah. Okay. So now, what I want to use, we don't have a lot of time. We have right at 25 minutes. So I want to take the remaining time. Hopefully we can get going kind of quickly. I got a little present for you all. It's a pop quiz. Yay. It's a present. It's a present. Yes. So let's try to be a little quick though. Let's finish as quickly as we can. So I'll give you about 20 minutes. I'm gonna stop the stream. We're gonna stop at 1:20. But if you guys can finish, sooner, that'll help. So just take one and pass it around. So it's coming around. You can. It's open notes. You can work together. You definitely wanna do the best you can here. Okay. And when you're done, just come turn it in, and let's try to finish quickly. I'll give you about 20 minutes. Yeah, just one, and 1, 2. Yeah. Yeah. Be sure to put your name, show your work, box your final answer, these kind of things. Pfeiffer. So you can work together. You can use your notes. It's a pop quiz. Yeah, I'm going to end the stream now. So be ready for exam 1 next Wednesday. We'll talk about the sections later. And be on the lookout for a study guide.